Okay, so let's go ahead and do one more example here. Where we can see what's happening with our integration by parts and our exception. And so this is my example number 2. Here I'm going to look at the integral of e to the 5x cosine of 3x with respect to x. And again, if you go through the process, you'll see that there's no basic rule that has a trigonometric function and an exponential in it. U substitution is not going to work here. As a matter of fact, we have two separate and distinct parts that cannot be combined. And so we're going to do an integration by parts. I noticed that neither of these parts will integrate to 0. So it really doesn't matter what I pick for u, as long as I pick the entire rest of it to be the dv. This time, just to switch things up, I'm going to let u be the trigonometric piece. Again, it's not necessary. You could let u be the exponential piece again if you choose to. You're going to get the same answer. But just to throw things up a little bit, I'm going to let u be equal to the cosine of 3x. And if that's the u piece, then everything else is going to be the dv. So the dv is going to be e to the 5x dx. As long as we stay consistent with both of our integrations here, it doesn't make any difference which one you pick. You're just going to have to work with whatever one you have. Well, let's start the way I have it here and go ahead and take our u and find our du. Remember that du dx is just the derivative of that side, and then multiplying both sides by dx. So I get du is going to be equal to a negative 3 sine of 3x. And let's talk about the reason for that. Well, the derivative of the cosine of 3x is the negative sine of 3x times the derivative of what's inside, which is that negative 3. So I have my u, I have my du, and sorry, that should be a dx there. My bad on that. And the only other thing I need is my v. V by definition is going to be the integral of dv. So this is the integral of 5x dx. That looks like an e to the u. And if I'm doing an e to the u, I'm going to need my u prime in there. And the u prime I need is a 5. So I'm going to need to multiply on the outside by that 1/5. Anything that you multiply on the outside with comes down, so the 1/5 comes down, and when I integrate e to the u times u prime, I simply get back that e to the u. So bringing down the 1/5, I get 1/5 e to the 5x. I now have all the pieces and parts that I need to do this first integration. So again, I started with the integral of e to the 5x cosine of 3x dx, which I turned into a u dv. And of course, we're remembering that this is going to be equal to uv minus the integral of v du. And I promise if you just write this out every single time you use it, it's going to help you to remember it come test time. So we're going to take our u and multiply it times our v, which is going to give me a 1/5 e to the 5x cosine of 3x minus the integral of v du. So minus the integral of 1/5 e to the 5x times negative 3 sine of 3x, and I'm running myself completely out of room here. Let's see if I can get a little bit more room here. Here, there you go, dx. Whew. Okay, I am going to definitely need to clean up that second integral. Let's see what it gives me. I've got a 1/5 e to the 5x cosine of 3x. The number here is going to become, let's see, I've got a negative here. When I multiply this negative 3 times 1/5, I'm going to get a negative 3/5. And with the negative on the outside, that's going to give me plus the integral of 3/5 e to the 5x sine of 3x dx. Didn't give myself a whole lot of room to write that in there. Okay, and so our second integral then is going to require us to do another integration by parts. As far as that 3/5, you can combine it with either of the two that you choose to. I guess I'll leave it with the e to the x, but again, the choice is yours. Now remember the last time we let u be the trigonometric piece, so we're going to need to do the same thing. We're going to let u be equal to the sine of 3x, which means then that the dv is everything else, which is a 3/5 e to the 5x dx. Now, again, based on that u, we can find du simply by taking the derivative and then multiplying both sides by dx. And when I take the derivative of this, I get 3 cosine of 3x, of course, dx. Again, reasoning being the same. When you take the derivative of a sine function, you get the cosine of that thing times the derivative of what's inside. So there's 2 of our pieces. The only other piece we're going to need is going to be the v. And I'm going to write that as 3/5 times the integral of e to the 5x dx. And once again, we've got here an e to the u. That means I'm going to need my u prime in here, so I'm going to need a 5 in here, which means I'm going to multiply on the outside by another 1/5. Again, anything on the outside is going to carry down, so I've got 3/25, and when I integrate e to the u times u prime, I simply get back, that e to the u. Let me get my eraser here and fix that. I'm going to get back simply that e to the u, or the e to the 5x. So once again, we've got all of our pieces and our parts. Let's see if we can go ahead and fill all this in. And so what we started with, again, was the integral of e to the 5x cosine of 3x dx, and that was equal to a 1/5 e to the 5x cosine of 3x minus, and now we have to, it was a plus, wasn't it? Because I'm looking from right here. And so I'm going to now use, remember what we're looking for, which is u times v minus the integral of v du. So that's going to look like our u times our v, which is 3/25 e to the 5x sine of 3x, and I'll drop down a little bit since I'm out of room, minus the integral of v du, which when I combine all that together there and pull the number out, I get 9/25 times the integral of e to the 5x cosine of 3x dx. And I'm going to break away for a minute. I'm going to put this on the top of another page so we can finish this up. Okay, I think we're ready to pick back up where we left off. So this was our final statement there after we did our integration by parts twice, and now we're going to perform a little bit of algebra, because remember, at this point, you should have back the same integral that you started with. And so we're just going to do a little bit of algebra. I want to move all of those integrals to the other side. I have a negative 9/25 of them on this side, so I'm going to add 9/25 of them to both sides. Over here, they're going to cancel out. And let's see what I get on this side here. 1 plus 9/25 is like 25/25 plus 9/25, which I believe will give me 34/25 times the integral of e to the 5x cosine of 3x dx will be equal to 1/5 e to the 5x cosine of 3x plus 3/25 e to the 5x sine of 3x. And then, of course, we will need to get that number away from our left-hand side. So why don't we come in and multiply this whole thing by, and I'll write this here, multiply, since I don't really have space on the other side, by the reciprocal, which is 25/34. And when we do that, I believe then we get, for our final answer, that the integral of e to the 5x cosine of 3x with respect to x will be equal to 5/34, and I believe when you flip that, when you multiply that through, that's what you're going to get, e to the 5x cosine of 3x plus 3/34 e to the 5x sine of 3x, all plus c. And this concludes our last video.